So here is another question on the concept of specific heat, latent heat, calorimetry, and the concept of heat loss and gain. So it is given that when 0.15 kg of ice at 0 degrees Celsius is mixed with 0.30 kg of water at 50 degrees Celsius in a container, the resulting temperature is 6.7 degrees Celsius. Calculate the latent heat of fusion of ice. Okay, so basically the condition is something like this. First, we have in a container this is 0.30 kg of water at 50 degrees Celsius. With this, we mix ice cubes or whatever ice at 0 degree Celsius. So what will happen? Let's see what will happen. Okay. First, the sequence of events that will take place. First, okay, not in this proper strict manner, but what will happen? The 0.30 kg of water, which is at 50 degrees Celsius, it will lower its temperature to 6.7 degrees Celsius because it is mentioned in the question that the resulting temperature is how much? Final resulting temperature is 6.7 degrees Celsius. So this is the final equilibrium temperature at which there is no more loss or gain of heat taking place. So when the temperature will be lowered from 50 degrees Celsius to 6.7 degrees Celsius, there will be loss of heat. Okay, it is heat loss in 0.30 kg of water. This is the equilibrium temperature, 6.7 degrees Celsius. Now this is for the water, 0.30 kg of water. Then for the 0.15 kg of ice at 0 degree Celsius, it will get converted into 0.15 kg of water at 0 degrees Celsius. Okay, ice will be converted into water, mass will stay the same. This is the concept of latent heat, using latent heat of fusion. This is specific heat. This is mc delta T, this kind of transition. And here this is Q equals to mLF, this latent heat of fusion. So here there will be gain of heat in ice, but this gain is hidden using latent heat concept. Here it is specific heat, here it is latent heat. So I have discussed it in detail, the concepts related to specific heat, latent heat, heat capacity, water equivalent, calorimetry. So please watch the theoretical videos, because here unnecessarily I don't have to go again through those theoretical concepts. So here the transition from ice to water takes place at constant temperature, because temperature is constant, there is not any increase or decrease of temperature. So this gain of heat, it is used up in the transition from ice to water. Then this 0.15 kg of water, this water, okay, at 0 degrees Celsius, after using latent heat concept, this, after it gets converted into water at 0 degrees Celsius, it gets converted into 0.15 kg of water at 6.7 degrees Celsius, the final equilibrium temperature. This is through the concept of specific heat. So there is heat gain. Here also there is heat gain, but here it is through specific heat. That is, Q is equal to mc delta T. The previous one is through latent heat, MLF. There it is mc delta T. So here also there is heat gain. So total we have these three events. One is heat loss through specific heat concept, where 0.3 kg of water at 50 degrees Celsius initially got converted into 3.30 kg of water at 6.7 degrees Celsius. So as temperature is lowered, there is heat loss. Then the 0.5 kg of ice, which was mixed with this 0.3 kg of water 50 degrees Celsius, it got converted into 0.15 kg of water at 0 degrees Celsius through latent heat concept. There is heat gain, but it is hidden. It is used up to convert ice to water at the same temperature. So here there is heat gain, but it is through latent heat. And then the 0.15 kg of water which we got here at 0 degrees Celsius, it got converted into the final equilibrium temperature 6.7 degrees Celsius through heat gain through specific heat concept. So here also there is specific heat. Okay, specific heat. Now we have to calculate these values. Sorry, delay. Okay, now we have to calculate these values. So first is the heat loss in 0.3 kg of water. Okay, heat loss in 0.30 kg of water as it it went transition from 50 degrees Celsius to 6.7 degrees Celsius. So here in the question it is given the specific heat of water which we want to use, that is equal to 4186 joule per kg per Kelvin. Now here it is given in Kelvin, but the information is given in Celsius. Here you have to understand, we discussed it in the first question I think, that any increase or decrease in temperature in Celsius corresponds to the same increase or decrease of temperature numerically in terms of Kelvin. So the difference of temperature, okay, the difference of temperature 50 degrees Celsius minus 6.7 degrees Celsius, whatever this difference is, it will be the same in terms of Kelvin. So let's say this is here 50 minus 6.7. So 50 minus 6.7, okay, 43.3. This difference 43.3 degrees Celsius, it was the same difference of 43 0.3 Kelvin. This is in degrees Celsius, this is in Kelvin. So it is the same. If we convert it into Kelvin also, we'll get the same difference. I have discussed it, in the previous question also, that in Kelvin and Celsius, the difference between temperatures numerically it is the same. So here it is the same as 43.3 Kelvin. So we'll try to calculate what is the heat loss. So the heat loss is equal to mW Cw delta T, where mW is the mass of water, Cw is the specific heat of water, and delta T is the difference of temperature. So 0.3 into 4186, the difference of temperature, 50 minus 6.7. Okay, so it is coming 54376.14 joule. Okay, here this concept we have used. Okay, even if it's in Kelvin and this is in Celsius, but because of this, the difference in temperature in Celsius and Kelvin is the same, that's why I've directly used this. So this is the heat loss. Then is the heat gained to convert 0.15 kg of ice to water at 0 degrees Celsius. That is the concept of latent heat. So that is equal to heat gain is equal to the mass of ice into latent heat of fusion. So this we have to calculate, the latent heat of fusion we have to calculate. So the mass of ice is 0.15 kg, so it is 0.15 into latent heat of fusion. Okay, only we'll keep it as it is. Okay, this is the first point. Okay, this is the first important thing, this is the second important point here. Then another heat gain, which is 0.15 kg of water at 0 degrees Celsius got converted into 6.7 degrees Celsius, the final equilibrium temperature. So also as there is increase in temperature, so there will be heat gain. So heat gain in 0.15 kg of water as it increased from 0 degrees Celsius to 6.7 degrees Celsius. So that heat gain is equal to mW Cw delta T, that is 0.15, specific heat of water again 4186, and here this temperature increase of 6.7 degrees Celsius minus 0 degrees Celsius, which is 6.7 degrees Celsius, it is the same as in Kelvin. That is, increase in 6.7 degrees Celsius is the same as increase in 6.7 Kelvin. So directly we'll use it 6.7. Okay, so it is coming around 4206.93 joules. So total loss, heat loss, will be equal to the total heat gain. So total heat loss is equal to, this is gain 1 in red from 0.15 kg of ice to water, plus the second gain here in blue. Okay, the total heat loss is equal to the total heat gain. So that implies this 376.14 joule is equal to 0.15 into latent heat of fusion plus 4206.93. This is the basic principle of calorimetry. The total heat loss is equal to the total heat gain. So that implies So that implies 54376.14 minus 4206.93 is equal to 0.15 LF. That implies the latent heat of fusion LF is equal to 54376.14 minus 4206.93 by 0.15. So it is coming around 3.34 into 10 to the power 5 joule per kg. This is the latent heat of fusion of ice. This is the final answer. Okay, so this question initially it can be a bit complicated. So my suggestion to you is that please watch the videos before solving this question. I have also repeated in the previous questions also. Please watch the theoretical videos related to specific heat, calorimetry, water equivalent, heat capacity, latent heat. I have explained in detail the whole transition from one state into another, the concept of heat loss, heat gain, latent heat, specific heat, everything I have explained in detail. So please watch those theoretical videos first and then watch these numerical videos. And wherever you have any problem, pause the video there, go back and forth and try to, grasp the idea there. Okay, so this is the concept.